Hi friends, welcome back to another video. So today I'll be explaining Physics May-June 2014 paper 32. Question 1 states figure 1.1 shows a distance time graph for a moving object. So this is a distance time graph. Part A states describe the speed of the object between points. Question 1 states A and B. So from A and B it's sloping downwards. The line is sloping downwards. So this means that the object is decelerating or slowing down. So you write slowing down, and then we calculate the speed, which is 30 divided by 15, which will be over here. 30 divided by 15 will be 2 meters per second. So the speed of the object from A to B is 2 meters per second, and it is slowing down. Then part 2 states between speed of the object between points B and C. So from B to C it's a straight line moving upwards. So this means that the object is moving at a constant speed. So write constant speed, and then we calculate the speed acceleration, which is here 50 minus 30, which is 20, divided by 40 minus 15, which is 25. So this will be 20 divided by 25 will be 0.8 meters per second. So in part 2, from between the points B and C, we'll write constant speed, and the acceleration is, and the speed is 0.8 meters per second. Then question B states, state whether the acceleration of the object is 0, negative or positive as shown on the graph between points A and B. So from point 0 to point B, from point A to point B, the acceleration is negative because it's curved downwards. So we write negative over here. And then for part 2, from points between B and C, it is a straight line. So the acceleration is 0 because it's not the speed of the object is not increased or decreased. So this ratio will be 0. Then question C states calculate the average speed of the object during the 40 seconds. So average speed is equal to total distance divided by total time. So the total distance traveled is 50 meters, over here 50 meters, divided by the total time, which is over here in the graph is 40 seconds. So we will write 50 divided by 40 is equal to 1.25 meters per second. So the speed of the object is 1.25 meters per second. Question 2 states a surveyor measures the dimension of the room of constant height. Figure 2.1 is a top view of the room and shows the measurement taken. Part A states state an instrument used that would be suitable to take these measurements. So answer will be a measuring tape. Then part B states the volume of air in the room is 76.4 meter cube. The density of the air is 1.2 kilograms per meter cube. Calculate the mass of the air in the room. So first you will write the density formula, which is P is equal to M divided by V. And in this you have to calculate the V. So write M is equal to P multiplied by V, where P is 1.2 kgs per meter cube, multiplied by 76.4, which will be 91.68 kilograms. So the mass of the air in the room is 91.68 kilograms. It is important to write a numerical form or the units in which you are measuring the mass. Like if it's mass grams, you write 91.68 grams. Over here it is kilograms per meter cube, so you write 91.68 kilograms. So this is what you will write. Then part C states the window in the room is open. The next day temperature of the room has increased, but the pressure of the air has stayed the same. How? State and explain what has happened to the mass of the air in the room. So the mass of air has decreased. As the temperature is high, air expands and becomes less dense, so the mass decreased. So this is what we will write in part C, that mass of the air has decreased because the window is open, and the pressure of the air has stayed the same because as air particles has expanded due to increase in temperature, they will become less dense, and so the mass has decreased. So this is what we will write. Question 3 states when a salmon swims up a river to breed, it often has to jump up waterfalls. Example 3.1 shows a salmon jumping above the surface of the water. On this occasion, the salmon falls back down into the river. So the salmon has a mass of 2 kg. The salmon leaves the water vertically with a kinetic energy of 16.2 joules. Calculate the speed of the salmon as it leaves the water. So we have the kinetic energy, which is 16.2 joules. We have the mass, which is 2 kilograms. So we have to calculate the speed. So we write k is equal to 1 over 2 mv squared. So we have to calculate the velocity. So v is equal to square root of 2 multiplied by ke divided by m, and 2 multiplied by 16.2 divided by 2, and square root, which will be 4.02 meters per second. So we write 4.02 meters per second as the speed of the salmon as it leaves the water. Then part 2 states calculate the maximum height gained by the salmon, ignore the air resistance. So we write Gp is equal to 1 over 2 mv squared, because potential energy is gravitational potential energy is always equal to the kinetic energy. So Gp is calculated by using mgh, which is mass times gravitational potential energy multiplied by height, is equal to the kinetic energy, which they already gave, which is 16.2 joules. So we write 16.2 joules. Then we will calculate the height, which is m is 2 kg multiplied by the gravitational potential energy, which is 10, multiplied by x is equal to 16.2. So x is equal to 16.2 divided by 2 multiplied by 10, which is 0.81 meters. So the maximum height gained by the salmon is 0.81 meters. Then part 3 states after the salmon has re-entered the water, it has lost nearly all its kinetic energy. State what has happened to the lost energy. So the question has 2 marks, so we have to write at least 2 points. So first is the lost energy is changed into heating of the water. So over here the lost energy has changed into heating of the water. As the salmon enters into the water, heat energy is released, so water around the salmon is heated. And then the second energy is sound energy, which is created when it touches the water surface. So these are the 2 statements that you have to write in part 3. Part B states another salmon of much greater mass leaves the water vertically with the same speed. State and explain how the height of this salmon jump compares to the height reached by the first salmon. So the height will be decreased because mass affects both kinetic energy and potential energy. So as gravitational potential energy as the mass increases, the gravitational potential energy will decrease, and this will affect the height of the salmon reaching the height that was achieved by the first salmon that was lighter. So this is what we will write in the statement. Question 4a states define the specific heat capacity of a substance. So the answer for the specific heat capacity of a substance is the amount of heat energy needed to raise the temperature of 1 kilogram of substance by 1 degree Celsius is called the specific heat of capacity. So this is what we will write as our final answer for question 4a. Then question 4b states figure 1.4.1 shows a cylinder of aluminum heated by an electric heater. The mass of the cylinder is 100 grams. The heater delivers 8700 joules of thermal energy to the cylinder, and the temperature of the cylinder increases by 12 degrees. So calculate the specific heat capacity of aluminium. So the specific heat capacity formula is C is equal to E divided by M delta costa, which is M multiplied by change in temperature. So energy that is put into the by the heater is 8700 joules divided by the mass, which is 800 grams. and then multiply by 12, which is the change in temperature from 0 degrees. So when we calculate this using a calculator, it will be 0.91 joules per kilogram degree Celsius. So we will write specific heat capacity is equal to 0.91 joules per gram degree Celsius. Then part 2 states calculate the thermal capacity of the aluminum cylinder. So thermal capacity is equal to E energy divided by delta Costa. So the energy is 8700 divided by change in temperature, which is 12. So this will be 725 joules per degree Celsius. So this is the thermal capacity of the aluminum cylinder. So we write 725 joules per degree Celsius. Then question C states, state and explain a method of improving the accuracy of the experiment. So by lagging the cylinder to prevent heat energy transfer to the surrounding. This is the sentence that we have to write in part C, which will improve the accuracy of the experiment. So no heat should escape from the cylinder into the surrounding area. So it is better by lagging the cylinder to prevent heat energy transfer to the surrounding. Question 5 states, puddles of water form path after rain fall on a windy day. In terms of molecules, state and explain how the state of evaporation of the puddles is affected by first a reduction of the wind speed. A reduction in the wind speed will decrease the rate of evaporation, because when water particles evaporate, there must be a space between the water particles and the empty air in which the waters can diffuse and evaporate. So this will reduce the this will decrease the rate of evaporation when the wind speeds are reduced. Then second question states, an increase of water temperature. An increase of water temperature will increase the rate of evaporation, because water molecules will be moving at higher speed and there are more chances that the water will evaporate and diffuse into the air. Then question B states, figure 5.1 shows two puddles. Then state and explain how the rate of evaporation from the large puddle compares to that from the small puddles under the same condition. So what you will write is, molecules in liquid evaporate from the surface area. This means that larger the surface area, the faster the rate of evaporation. So the rate of evaporation is more in large puddle as compared to small puddle. So this is the whole explanation that we have to write in question B, and this is the final answer. Question 6a states, figure 6.1 shows a ray of incident on the surface of the glass block. On 6.1, accurately draw the reflected ray. So first we will draw a perpendicular line on the surface of the glass, which is 90 degrees straight, and then we will draw a light ray from here, which is at 45 degrees, and then a reflected ray will also be at 45 degrees. So we will draw a constant even line from the left side hitting the glass and then reflecting back into the air. So this is how we will draw a ray of light incident on the surface of the glass block. Then question B states, figure 6.2 shows a ray of light incident on a glass prism. Put one tick only in each line of the table to indicate which of the angles labeled in 6.2 are the angle of incidence and the angle of refraction. So over here for angle of refraction this is the angle when it's entering into another medium. So over here, this is the perpendicular line on which the light ray is hitting, and then from here it went towards inside of the prism. So this letter, which is the V, is the angle of incidence. So we write angle of incidence as V. Over here we will take V, and then angle of refraction is when the angle that is made when it enters into a new area, which is the prism. So over here Y will be the angle of refraction. So we'll take y as the angle of refraction. Question C states the refractive index of water is 1.33 and a ray of light passes from the water into air. The angle of incidence at the water-air interface is 30 degrees. So the angle of incidence for sine I is 30 degrees. So we have to calculate the angle of refraction. So the formula of refractive index is n is equal to sine I divided by sine r. So we have to calculate the sine r. So write sine r here 1.33 is equal to sine 30, which is sine I, divided by sine x, which is sine r. Then we write x, which is the refractive index. Angle of refraction is equal to sine inverse sine 30 divided by 1.33 brackets close, which is 22.1 degrees. So the angle of refraction is 22.1 degrees. And we will write this as our final answer. Then question D states figure 6.3 shows rays of violet and red light incident on the prism. The dashed line shows the path taken by the ray of violet light in the prism. Draw a labeled path of the ray of red light takes in the prism. A calculation is not required. So if this is a violet ray, then we will mark a line which is above the violet light and in a good distance around 1 to 2 centimeter, because the first light that is emitted by the prism on the top is red light and the last is the violet. So we will mark a straight line over here for the red light. Question 7a states a solenoid connected to a battery produces a magnetic field. The wires are then connected to the battery terminals of the other way around. Take one box in the table to indicate the effect of the magnetic field. So the magnetic field over here, if the battery terminals are turned around or turned the other way around, so this will reverse the direction and decreases but not to zero. This is also wrong because the two sides are changed, so it will be a reverse direction. And over here it decreases to 0, which is also wrong. It increases, which is also wrong because we did not increase the battery size or made the battery stronger. So this will be also wrong, and stays the same, which is also wrong because it is not in the same terminals. It is turned the other way around. So reverse direction will be the correct answer for 7a. Then 7b states figure 7.1 shows a top view of two bar magnets and a vertical rigid conducting rod carrying a current. The direction of the current in the rod is coming out of the paper. So figure 7.1, draw a single line with the arrow to show the direction of the magnetic field due to the bar magnets at the position of the rod. So over here a vertical rod is placed perpendicular to the paper. So the magnetic field lines will be from north to south, passing through the paper and the vertical rod in perpendicular. And then state the direction of the force exerted on the vertical rod. It will be attracted towards the it will attract both the magnet towards it. So this will be the final answer for part 2. Then question C states the rod has a mass of 350 grams and the resultant force acting on the rod is 0.21 newtons. The rod is free to move. Calculate the initial acceleration of the rod. So the for acceleration of the rod is F is equal to ma, then A is equal to force divided by ma. So the force over here is 0.21, so I write 0.21 divided by the mass, which is 350 grams. So this will be 0.0006 meters per second. So 0.0006 meters per second square will be the initial acceleration of the rod. Question 8 states figure 8.1 shows 3 cells each with EMF of 1.5 volts connected in a series. Part A states calculate the combined EMF of the cells. So we have 3 EMF, which is 1.5, 1.5 and 1.5. So we'll write here 1.5 plus 1.5 plus 1.5. which will be 4.5 volts. So 4.5 volts will be the final answer, and it will be the EMF of the cell, combined EMF of the cells. Then part B states calculate the combined resistance of the three resistors shown in figure 8.1. So over here, first we will calculate the combined resistance of these two resistors, which is 4 and 1. We will write for R is equal to R1 plus R2, which is 4 plus 1, which is 5 ohms. And then the other resistor over here, which is 1 ohm, we will write R1 multiplied by R2 divided by R1 plus R2. So 5 multiplied by 1 ohm divided by 5 plus 1, which is 5 divided by 6, and this is 0.83 ohm. So the combined resistance of the three resistors are 0.83 ohms. Then part C states calculate the current in the 4 ohm resistor in figure 8.1. So current is equal to 4.5 because we have calculated the combined current, which is 4.5 divided by 5, which is the resistance through the current in 4 ohm resistor, so which is 0.9 amps. So 0.9 amps will be the final answer because we divided the combined current, which is 4.5 divided by the resistance through the resistor. Combined resistance is 4 plus 1, which is 5. So 4.5 divided by 5 will be 0.9 amps. So this will be the final answer for part C. Question D states calculate the combined EMF of the cells if one cell is reversed. So the combined EMF is 1.5 volts because if one cell is reversed, that's the EMF that is being used in the whole circuit then. So it will be 1.5 volts. Question 9 states figure 9.1 shows a positively charged plastic rod, a metal block resting on an insulator, and a wire connected to the earth. So we have a wire connected to the metal block with an insulator at the base, and over here we brought a positively charged plastic rod. So what will happen is all the negative particles will move towards this side of the block, upside of the metal block, and all the opposite charges, the positive charge, will move down to the base of the metal block. So we will put minus signs over here and positive signs at the base of the metal block, like this. Then figure B states the earth wire is held against the metal block as shown in 9.2. On figure 9.2, draw the new charge distribution. So once the wire is connected to the earth, all the positive particles which I have shown in question 1 will move through the correct wire into the earth. So only negative particles will remain in the metal block. So this is the new charge distribution of the metal block. Then part C states the charged rod and the earth wire are removed and the metal block is left charged. State the order in which the rod and the wire were removed. Explain your answer. First, the wire was removed, then the positively charged rod is removed from the metal block. So the charges are kept in the block. So you have to write what's the state the order in which the rod and the wire were removed. Explain your answer. So first the wire is removed, then the positively charged rod is removed from the metal block, so the charges are kept in the block. Then part D states name this charging process charging by induction. So this will be the answer for question D. Question 10a states figure 10.1 shows a digital logic circuit using the recognized symbols. So this is the logic gate, and complete a table showing to indicate the logic points of point D, E and E in the circuit when points A, B and C are at the logic levels indicated. So first at A, if the power is 0, and at B, if the power is 0, then the AND gate will also be 0. So D will be 0. Then if input C is 0 and D is 0, OR gate, it will be 0 because it will choose either this path or this path. So both are 0, then output E will also be 0. Then if A and B are 0, D will be 0 because both are 0, as in first explanation. Then when C is 1, the OR gate, when C is 1 and D is 0, the OR gate will choose the high voltage and output will be 1. Then over here, when A and B is 1 and then D will also be 1, then C will be, if C is 1 and D is 1, then OR gate will choose both and each of them, so it will be 1, so output E will be 1. So this is how we will represent 0 and which is off or low, and 1 as high or on in this graph. Then question B states, draw the recognized symbol for an AND gate. So first we will draw two parallel lines and draw an extended D line, letter D over here, and then we will again put a line from the middle of the D to the right side, and this is how we will symbol of AND gate will be drawn. Then a NAND gate can be replaced by an AND gate and a NOT gate. Draw the diagram to show the AND gate and the NOT gate should be connected. Label clearly the logic gates and input or output. So first we will draw an AND gate like this, and then we will connect a NOT gate in front of the AND gate and label it as output. Over here we will write NOT gate, and over here we will write AND gate, and over here we will write input. So these are the 4 labels that you have to write, or else you will not get 2 marks. Question 11 states, figure 11.1 shows a beam of radiation that contains alpha particles, beta particles and gamma rays. The beam enters a very strong electric field between charged plates in a vacuum. So this is a beam of radiation passing through between the plate of positive voltage and plate at negative voltage. So A states indicated deflection if any of the alpha particles, beta particles and Y rays by placing one tick in each column of the table. So first is the alpha particles. When the alpha particles are positively charged, so they will move towards the negative voltage plate. So we'll write towards the negative plate. Over here we will put a tick. Then for beta particles are negatively charged, so they will move towards the positive voltage or positive plate. So we will tick over here towards the positive plate. And for gamma rays, they are negative. They have no charge, so they will pass through between the plates without deflecting towards the positive or the negative. So no deflection. We will put a tick over here as for no deflection. Then part B states the radiation is said to be ionizing. Explain what this means. So the formation of ions as a result of radiation by knocking electrons from atoms is called ionization. So guys, if you can't read this or you cannot read this, so you can comment me and then I will write the answer in the comment section. So the formation of ions as a result of radiation by knocking electrons from atoms is called ionization. Then alpha particles, question C states alpha particles are more strongly ionizing and have a shorter range in air than Y rays. Use your knowledge of the nature of this radiation to explain these differences. So alpha particles have 2 protons and 2 neutrons. Y rays has protons and neutrons. Alpha particles are stopped by paper and Y rays are stopped by 6 cm thick concrete wall. We can also write X rays have mass and gamma rays have mass, and gamma rays do not have mass because it does not have protons and neutrons. And then gamma particles are large in size and gamma have a negligible size. So alpha travels slowly and gamma rays travel faster, and gamma travel at a speed of light. So this is what we will write. I will explain again. Alpha particle has a mass and gamma rays does not have a mass because gamma rays does not have a proton and neutrons. Alpha particles has large size and gamma rays has negligible size. So alpha travels slowly and gamma rays travel faster. So gamma rays travel at the speed of light. This is what we will write in question C.